All right, it is time to take a look at part B of this question. Part B asks if the amount of water in the pipe is increasing or decreasing at t equals 3 hours. Okay, and one of the things you have to keep in mind here is you have rates. We can see the overall functions here. Okay. By the way, in the previous problem, it turned out that 76.570 cubic feet of water came in. Maybe always round to at least 3 decimal places when you run those numbers. Anyway, part 2 asks if the amount of water in the pipe is increasing or decreasing. The big thing you want to think about here is these are both rates. That's not the amount of rainwater total that's fallen. That's not the amount of rainwater that's left. This is how fast it's coming in cubic feet per hour. This is how fast it's leaving in cubic feet per hour. Okay, so you kind of have to think about the units. Sometimes I just pull away from the problem and I think, okay, water's coming in at, let's just make up a number, 10 cubic feet per hour, and water is leaving at 3 cubic feet per hour. How do I tell if the amount of water in the pipe is increasing or decreasing? And you think about that a little bit and you realize, oh, well, if this amount comes in and this amount goes out, how much water total is left in the tank? 7 cubic feet per hour remains in because it's not leaving as quickly as it comes in. The point here is you subtract the rate at which it's leaving from the rate at which it comes in to tell you the total rate over a particular time period. Okay, so you can take the rate in minus the rate out. And then, of course, if you take an integral of rates, it tells you the total amount over that time period. Okay, so you can take the integral. I'm not going to write all this down, but the overall rate, the rate at which it comes in is R of t, and the rate at which it leaves is d of t. Okay, so the overall rate would be how much comes in minus how much goes out. Okay, now keep in mind that's per hour. Okay, we're looking at this. Basically, we want to find the rate. Oh, you know what? I don't even need an integral here. These are already rates. So I can just figure out what's the rate at t equals 3. It wasn't the total amount of water that's come in over the first 3 hours. It's just at that split second time, what is the rate? So I can find the rate at 3, and I can find the rate that it's leaving at 3, and I can just subtract those two rates. And actually, if you do subtract those two rates, so if you sub in 3 to this function, and you sub in 3 to this function, and you subtract, you apparently get approximately negative 0.313. And again, that's a rate of change. That's cubic feet per hour. Okay, so the amount of water would be decreasing. Okay, in other words, right now, water's leaving faster than it's coming in. And I think if you run those two numbers, you'll be able to see that. But that's really interesting. So really be careful there. Check and see, is it the rate that they give you, or is it the total amount? And you need to think about, if it's a rate, are they asking you for a rate, or are they asking you to find a total over an amount of time? Okay, if you integrate the rate, it'll tell you how much occurred over a time period. If they're just asking for the rate at 1 split second time, you're just putting the number into that rate function. Okay, so you have to read these things very carefully. But that's all that's going on in Part B.